Hello students, let us take another example of the DTFS. So here they have asked to find the DTFS of a sequence which is given below. If I just try to plot the sequence, it will look something like this. At n is equal to 0, I am having a value which is 1. At all other times, its value is 0. Then at 4, I am having another value of 1. Then again 4 zeros and then again 1. And like that, this sequence will go. Similarly, in the negative axis also, it is going something like this. This kind of sequence is called as a train of impulse. Okay, generally train of impulse does not have zero value in between, but I'm just saying, it just looks like a train of impulse. Or you can say that in the previous problem, we had, represented 5 values as 1 and then the next 5 values as 0 and then again the 5 values as 1. So it looks somewhat similar with, all the values of 1 being taken out other than just keeping 1. And that's how we have got it. Let us see how easy the the discrete Fourier series of this one is easy to find out. Okay, so let us do it. So the first thing here that we have to see is what is the period. The period n0 is going to be equal to, from here to here I can say, so it is going to be equal to 4, correct? So the periodicity is 4. Therefore, I can say that omega naught is going to be equal to 2 pi by 4, which comes out to be pi by 2, correct? Now let us write the equation. The equation we all know that we can find out the DTFS of a periodic signal by using the equation x of k is equal to 1 by n naught summation n values within the period xn e raised to power minus j k omega naught n. Let us substitute the values. N naught is 4. The limit is going to go from n is equal to 0 to 3. Correct? 0, 1, 2, 3. So that is the period. So from 0 to 3, and at that the values are going to be xn e raised to power minus j k omega naught is pi by 2 into n. Correct? Okay. Now look here. The value of xn is going to be 0 for 1, 2, 3. That means for n is equal to 1, n is equal to 2, n is equal to 3, the values of this is going to be 0 and only it exists for n is equal to 0. So it comes out as x of k is equal to 1 by 4, and then within the bracket I am having x of 0 which is equal to 1, which comes out to be e raised to power minus j k pi by 2 into the value of n here is 0, isn't it? This was for n is equal to 0, and then for all other values of n, that means n is equal to 1, 2, 3, I am having the value 0, so it will be 0, plus for n is equal to 2 it will be 0, plus for n is equal to 3 it will be 0. And what is this value? This value is just 1. Which one? This one is just what? E raised to power minus j k pi by 2 into 0 is as good as e raised to power minus 0, which is 1. So the answer comes out to be 1 by 4. So how do we plot it? So either we can say that the Fourier series of this, the magnitude spectrum. So if I have to draw the magnitude spectrum, see here, whatever be the value of k, the answer is going to be 1 by 4 always. So this has become a very easy question, isn't it? Because the value of k does not matter, because for n is equal to 0, this whole term is going to be e raised to power minus 0, which is 1. So all the time your answer is going to be 1 by 4. So the magnitude spectrum, if I have to draw, I will draw like this. The xk value is basically, let me draw it. So x of k, I can draw it like this. All of these are having a height of 1 by 4 for k is equal to 0, 1, 2, 3, 4 for all the values beyond that also, and here also for -1, for -2, -3, its value is all going to be 1 by 4, and this is x of k magnitude, and this value is based on k. So this is the magnitude spectrum. As you can see, if I am trying to plot, it is basically a constant value of 1 by 4. It's a constant value of 1 by 4. So that is the case for this particular sequence. Let us do another problem. Find the DTFS of the following. We are having 3 signals. Let us do it one by one. First is x of n is equal to cos pi by 4n. The first thing that we have to ascertain is that it's a periodic signal and that the period of that has to be found out. So pi by 4 into n. So generally for a periodic signal, so I will write for a periodic signal, the condition that we always have is that cos of pi by 4 n should be equal to cos of pi by 4 n plus capital N naught. In that case, it's a periodic signal, isn't it? Which I can write it as cos pi by 4 n plus pi by 4 capital N naught. And when is a cos signal going to be periodic? So I will write for which pi by 4 n naught, which is this second part. This second part should come out to be 2 pi. Then only this particular condition will be satisfied. We know that every cosine signal has a periodicity of 2 pi. So based on that, this should be equal to 2 pi, from which I will get therefore n naught is equal to 8. Okay, so we have found out the periodicity of the signal. Okay, it's a periodic signal with a period 8. Now next what we have to do is we have to find out the DTFS. Now here in these cases, that means when you are having cosine, sine signals and all, there is a different method that we adopt. We can do it in the method that we have studied, but there is a slightly different method that we adopt. I am going to show you that. We know from the Euler's relation, or the Euler's formula, we know that any value cos theta can be written as e raised to power j theta plus e raised to power minus j theta divided by 2. So we will use the same formula here, and we will write therefore cos pi by 4 n can be written as 1 by 2 e raised to power j pi by 4 n. Let me write it properly. J pi by 4 n plus e raised to 1 by 2 e raised to power minus j pi by 4 n. So this I will name it as equation 1. Okay, suppose I am going to name it as equation 1. Why I am writing it in this form is because if you see this, the equation, you will feel as if it is already having a DTFS format. So what we will do is we will do a comparison between the two equations. So how we are going to do? So we know that, next I will write, since it's a new page, I will write the equation back. so that we are able to compare. So it is cos pi by 4 n can be written as 1 by 2 e raised to power j pi by 4 n plus 1 by 2 e raised to power minus j pi by 4 n, and this is our equation 1. Okay, now from DTFS we have already seen what is the equation that we get. If we know xn, we get x of k. Now suppose if we know x of k, we can find out x of n. And what is the formula for that? We have already seen that formula, that if we know x of k, then the inverse is basically given as x of n is equal to summation k is equal to, within the limits of period n naught, okay, capital X of k e raised to power j k omega naught n. Okay, what is omega naught here? Since the periodicity is 8, I will get 2 pi by 8, it is going to be pi by 4, correct? Omega naught is pi by 4. So I will use that to write this as x of n is equal to summation. So I will start from 0. So n is equal to, not n, k, small k is equal to 0 to n naught minus 1, which in our case n naught is 8, so this will come as 7. X of k e raised to power j k, omega naught is pi by 4, and then n, correct? So now if I expand this equation, so therefore x of n is equal to, now I am going to expand this equation right from 0. So I will get capital X of 0, and if I put here 0, then I will get into 1 plus the next value for k is equal to 1. I will get capital X of 1 e raised to power j, k is equal to 1. So what remains is pi by 4 n plus x of 2 e raised to power j 2 pi by 4 n, okay, 2 pi by 4 n plus x of 3 e raised to power j 3 pi by 4 n plus x of 4 e raised to power j 4 pi by 4, which is pi n. Then we are having x of x of 5 e raised to power minus, j, then 4 is over 5 pi by 4 n plus x 6, like that I can keep on writing. Okay, now this is something that we have to compare it with the above equation, but see, in the above equation we are having negative values, isn't it? We are having e raised to power minus j values. So what we do here is, instead, so because we will not be able to compare, so what we are having plus values here as well as minus values here. So if I am going to take from 0 to 7, I will only get positive values. So instead what I will do is, I will take the period of n naught is equal to 8, and I will start from such a value that I am having negative as well as positive sides in the equation. So if we are having 8 values, we will think that, okay, 4 values we will take here and 4 values we will take here, but in between there is a 0, so that will become 9 values. So we will say that, okay, we will take 3 values in the negative axis and 4 values in the positive axis and a 0. That will give me a total periodicity of 8. So I will start from -3 and go all the way up to +4. So I will change this and I will now rewrite this as k is equal to from -3 to +4. So as you remember the rule, you can take the period to start from anywhere. So this is what we are trying to do here. So if that is the case, then we will have to rewrite this equation as, for -3, capital X of -3 e raised to power j minus 3 pi by 4 n plus x of -2 e raised to power minus j 2 pi by 4, it will become pi by 2. Okay, pi by 2 n plus x of -1 will become e raised to power minus j pi by 4 n, and x of 0 will become x of 0. So x of 0 e raised to power 0 is 1. So next x of 1, let me write it down, plus x of 1 e raised to power j pi by 4 n plus x of 2 e raised to power j 2 pi, since it is 2 pi by 4, so it becomes pi by 2 n plus x of 3 e raised to power j 3 pi by 4 n, and in the end it is x of 4 e raised to power j pi by 4 pi by 4 is pi n. So this is the equation, and this equation I will name it as equation number 2. Okay, equation number 2. Now look at equation number 1 and equation number 2. Equation number 1 says that this equation has only two parts, this one and this one. So one positive e raised to power positive j pi by 4 and another is e raised to power minus j pi by 4 n. I have to search where I will have this e raised to power j pi by 4. You can see this thing, x1 e raised to power j pi by 4. So one thing that we can say by comparing both this and this equation is that x1, x capital X of 1 will be equal to 1 by 2. Similarly, e raised to power minus j pi by 4 is here. So I can say that x of -1 will be equal to 1 by 2. Rest all these values are not to be found. Only these two values are to be found. This one and this one. Only these two values. The rest are all zeros. So I will conclude and see x of -1, according to this equation it is going to be 1 by 2. X of 1 again according to this equation is going to be 1 by 2. So using that concept, I will write only for these two values the value as 1 by 2. So I will write, therefore comparing equation 1 and 2, we can say that capital X of 1 is equal to 1 by 2, capital X of -1 is equal to 1 by 2. All the other values right from x of -3, same as x of -2, same as x of 0, same as x of 2, same as x of 3, finally same as x of 4. All of these are having a value of 0. So you can see that very quickly, just by comparing these two equations, I have found out the discrete time Fourier series of a cosine signal, something like this. For this particular signal, just write the equation compare it with the equation here, and then find out the values. Remember, this is the important part, that you should have negative as well as positive values of k. Okay, the next question, which is the second one, it's slightly different. We are having x of n is equal to cos pi by 3n plus sine pi by 4n. Let me write it properly. Pi by 4n. Now here we are having two signals. One is cos pi by 3n and another is sine pi by 4n. Both of them are periodic in nature. We suppose first one is having a period of n1 and second one is having a period of n2. Then what will be the period of the signal x of n? This we have already discussed in the periodicity examples that we had done in module number 1 to find the periodicity of a discrete time sequence. In that portion we have already done. I will rewrite the rule here. The rule is, if x1 of n has a period of n1 and x2 of n has a period of n2, then the linear combination, that means the addition of these two periodic signals, will have a new period, and that period will be given by the LCM of n1 and n2. So based on that, let us do the calculation. So we are having cos pi by 3n, therefore cos pi by 3n will have a periodicity which will be given by cos pi by 3n n plus n1. Okay, will have a periodicity when this becomes equal. If this is equal to this, which can be written as cos pi by 3n plus pi by 3n1. Therefore, according to periodicity, pi by 3n1 should be equal to 2 pi. Therefore, n1 is equal to 6. Similarly, if I am trying to look for sine, so sine pi by 4n will be equal to sine pi by 4n plus capital N2, which can be written as sine pi by 4n plus pi by 4n2. Okay, in that case I will get, therefore pi by 4 n2 should be equal to 2 pi for periodicity. Therefore n2 is going to be equal to 8. Hence, okay, hence x of n has period which is given by taking the LCM of signal n1, of period n1, which is 6, and period n2, which is 8. See, if there would have been 3 signals, then I would have written a third signal's period here. Any number of signal periods you can write, and you can take the LCM of that. So here the least common multiple will be 24. LCM of 6 and 8 is 24. So now the period, therefore n0 is equal to 24. So the period is now 24. So just have a look. We are going to now expand. So this is the signal x of n. Let us expand it using the Euler's relation. So cos gets expanded as 1 by 2 e raised to power j pi by 3n plus 1 by 2 e raised to power minus j pi by 3n, whereas the sign gets expanded into 1 by 2j e raised to power j pi by 4n plus 1 by 2j, not plus but minus, sorry, minus 1 by 2j e raised to power minus j pi by 4n. Let me write it properly. Pi by 4. Pi by 4n. Okay, so these are the values of x of n. Now I can compare it with the x of n using the DTFS. We know that omega naught is equal to 2 pi by n naught. Here n naught is 24, so we get pi by 12. Omega naught is pi by 12, and we know that x of n is basically given as summation. So now I have to start, since n naught is 24, I will start from minus 11 all the way up to plus 12. Okay, so I will go from k is equal to minus 11 all the way up to plus 12. Okay, all the way up to plus 12, and the values are going to be x of capital X of k, capital X of k e raised to power j k omega naught, which is pi by 12. Okay, but let me just write omega naught n. I will write, instead of omega naught, I will write pi by 12. Okay, so let me write pi by 12 n. Now you can compare without expanding. See, no need for you to expand, because all you are trying to compare is with these values, isn't it? That means e raised to power components you are trying to compare. So tell me, when will you get, at what value of k will you get pi by 3? So the question is, I will write it here, that at what value of k will e raised to power j k pi by 12n become e raised to power j pi by 3n? At what value of k? So we can very clearly see that 12 is 3 into 4. So if I write k is equal to 4 pi by 12, then 4 and 12 will cancel out to give me pi by 3. So that pi by 3, if I want to get here, so I will get, for k is equal to 4. And if I want minus pi by 3, then k is equal to minus 4. So comparing, so I can directly write, so this is equation 1, this is equation 2. No need for me to expand it as in the previous case. For k is equal to 4, e raised to power j k pi by 12 of n becomes e raised to power j pi by 3 n. Correct? For k is equal to 4. Similarly, I can write, and k is equal to minus 4, the equation e raised to power j k pi by 12 n becomes e raised to power minus j pi by 3 n. Therefore, this value will be what? This will be, for k is equal to 4. So, therefore, x of 4 will be equal to 1 by 2, and x of minus 4 will be equal to also 1 by 2. Similarly, if I want to get this equation, look at this equation. If I want to get these two equations, you can see that if I put the value of k is equal to 3, here, I will get 3 into pi by 12 as pi by 4, which is basically this value. So similarly, for k is equal to 3, e raised to power j k pi by 12 n becomes what? E raised to power j pi by 4n. Similarly, and k is equal to minus 4, e raised to power j k pi by 12n becomes e raised to power minus j pi by 4n. Therefore, I can say, not minus 4, sorry, this should be minus 3. Okay, therefore, I can say that x of 3 is equal to, now look at these values. Here it is plus 2j, 1 by 2j, and here it is going to be minus 1 by 2j. So I can directly write it as x of 3 is going to be plus 1 by 2j, okay, and x of minus 3 is equal to minus 1 by 2j, and x of k is equal to 0 for all other values of k between minus 11 and plus 12. Okay, clear? So this is what the answer will be for this particular case. So you can see that once we have found out the periodicity, and based on that, if we are going to write the values, it's quite simply we will get the values very accurately here. Okay, next is x of n is equal to cos square pi by 8n. See, one of the ways is we expand it with the relation that cos square theta can be written as 1 plus cos 2 theta divided by 2, and then split it up as 1 by 2 and cos 2 theta by 2, and then follow, just like we have done previously. Or what we can do is we can take the Euler's relationship and then take the square of that. So what is the Euler's relationship of this? E raised to power j theta, which is pi by 8n divided by 2 plus e raised to power minus j pi by 8n divided by 2, the whole square. So considering this as a and this as b, a plus b the whole square, we all know is a square plus b square plus 2 times ab, correct? So I can write, therefore, let me write it here, therefore x of n is equal to e raised to power j pi by 8n square, which comes out to be pi by 4n, divided by 2 square, which is 1 by 4, plus b square, which comes out to be again 1 by 4 e raised to power minus j pi by 4n, and what remains is 2 times ab. So a is this, b is this. If we multiply both of them, then I will get 4 in the denominator, then 2 times ab, so 2 in the numerator. Now a into b, as you can see, if I multiply these two, a into b, then basically both of them will cancel off, because this minus the second one, we will get e raised to power 0, which is 1. So I will basically write this as 1. Okay, remaining let me rub off. Okay, which now I can rewrite it as, it's very simple, e raised to power j pi by 4n into 1 by 4 plus 1 by 4 e raised to power minus j pi by 4n plus 1 by 2. Okay, I'll just write e raised to power 0 here because to show something. Generally, no need to write e raised to 0 because e raised to 0 is equal to 1, but for the comparison purpose we may have to write. What is the period of the signal? So for finding period, we have to know that we have to say that cos of pi by 8 n square should be equal to cos of pi by 8 n plus capital N naught the whole square. Correct? The whole square, which basically transforms as cos pi by 8 n plus pi by 8 capital N naught the whole square, which I will just write like this. Therefore, for periodicity 8 pi by 8 n naught pi by 8 n naught should be equal to 2 pi, or is it 2 pi? That's a question. Can we write like this? Just look here. See, if suppose I am having a cosine waveform is like, let's say I am drawing like this. If I take the square of it, what will come? It will come like this. The square of the cosine waveform will come something like this, isn't it? So what has happened? Previously, when this much was the period, now the period has got actually half of that. So since 2 pi becomes a period of pi, so here instead of the periodicity becoming this, I will basically write that the periodicity has to be done with pi. In that case, therefore, n naught is going to be equal to 8. Okay. So now we have got the periodicity, we have got the equation of x of n. I will again write this x of n equation in the next page. So rewriting the equation in the new page, and we know through DTFS equation, inverse DTFS, I will have the summation. Now where do I start from? Since n naught is equal to 8, I will start from again minus 3 and take it all the way up to 4. So I will write for k is equal to minus 3 to 4 x of k e raised to power j k omega naught. What is omega naught? Omega naught is equal to 2 pi by 8 n naught is equal to 8, which is basically pi by 4. So pi by 4, let me write it more neatly, k pi by 4 n. Okay, so the remaining I will just rub it off, where omega naught is equal to 2 pi by 8, which is equal to pi by 4. This is my equation number 2. So comparing 1 and 2. So if I am going to compare 1 and 2, what will I see? So at what value of k will I get this value? You can see that at k is equal to 1, I will get that value. Similarly, at k is equal to minus 1, I will get that value. So I will write capital X of 1 is equal to capital X of minus 1. That means if I put the value of k as 1 and minus 1, I will get these values. Therefore, the x of k value will be equal to 1 by 4, because here also it is 1 by 4. Okay. When do I get 0? 0 will be possible only if the value of k is equal to 0, because n is not in our hands, only k we can choose. So, and x of 0 is equal to how much? 1 by 2. Rest all the values. Rest x of k will be equal to 0 for k, which are the values of k? It is starting from -3. So -3, -2, -1 we have used, 0 we have used, 1 we have used, 2, 3 and 4. So that is how, using the comparison method, we can find out for the special cases of sine and cosine signal. So if you have to find out the equations of the DTFS values of sine and cosine signal, this is the format that you use, or this is the general method that you use. Thank you.